Precipitation. As we know, water evaporates off of all surfaces on our planet. Eventually that water condenses, forms clouds, and as condensation droplets get larger and larger, they eventually become so heavy that gravity can pull them down. We call this precipitation. So eventually all water makes it back to the surface of our planet. Precipitation is any form of water that falls from clouds and reaches our surface. Common types of precipitation are rain, sleet, snow, hail, and freezing rain. And we're going to look at each one of these. So starting with rain, it's the most common type of precipitation. Water droplets have to be at least half of a millimeter in order to be considered rain. If the water droplets are smaller than a half of a millimeter, we call it drizzle. And if the droplets are even smaller than drizzle droplets, we consider that mist. Mist usually kind of hangs in the air a little bit longer, doesn't fall quite as easily. So it's a little bit more like taking a spray bottle and kind of spraying a little moisture in the air, and you can kind of walk through it without it falling to the ground quite as quickly. So we measure rain by using a device called a rain gauge. This is a picture of a rain gauge. Notice at the top of the rain gauge there is a funnel shape, and then also there's on this one there's a measuring device inside of that rain gauge. You can either take a ruler and just simply measure the amount of water that's inside the tube, or many of them have that scale that's right on the rain gauge. Many of them use that funnel to collect a larger amount of water over a larger area. And usually that area is 10 times larger than the area that we actually use to measure the amount of rainfall. So what we do is we just look at the amount that's inside the rain gauge, we divide that by 10, and that would give us an accurate representation of the amount of rain that fell over a period of time. The reason that we use the larger funnel at the top is because the depth is easier to measure in that case. And it kind of helps us get the actual depth of rain that fell, instead of looking at it and trying to measure a very small amount inside of a tube. So if we use the larger scale with the funnel on it, we just need to divide by 10. Here's another picture of a rain gauge, but a little bit better of a representation of it. Kind of can see that funnel shape at the top a little better. Freezing rain. Freezing rain occurs when raindrops, as they fall through the atmosphere, they eventually hit a surface. The surface must be extremely cold, and it causes that rain to actually freeze to the surface that it came in contact with. So this typically happens on cold days where the atmosphere may be right around that 32 degrees Fahrenheit mark, or maybe just a slight bit cooler. Where we're still getting precipitation that falls in the form of rain, but once it comes in contact with the surface or any object on the surface, it quickly freezes. Here's a picture of freezing rain. Snow. Snow forms when water vapor in a cloud is converted directly into ice crystals. Snowflakes often join together into large clumps of snow, which the crystals are hard to see in this case, but we get these very large clumps of snow where the crystals are kind of all stuck together. And as, again, they become heavier and heavier, they eventually fall back down to the surface. Hail. A hailstone is a round pellet of ice that's larger than 5 millimeters in diameter, so it's about a half of a centimeter. A picture of some hailstones. So if you cut a hailstone in half, you can see layers of ice. Hailstones form inside cumulonimbus clouds during thunderstorms. The hailstone starts as an ice pellet inside a region of the cloud, and the reason we get those layers inside of a hailstone is because those layers of ice are kind of laid down on top of that small pellet due to updrafts that occur inside of the thunderstorm cloud. So high winds push that hailstone up in the air, and it goes higher and higher, and we know the higher in the atmosphere you get, the colder it gets. So any water that's on the surface freezes, that hailstone falls back down where it is re-moisturized, I guess is the best way to say that, as it goes through the cloud, and then updrafts lift it back up where it's refrozen over and over and over again. The more times that happens, the larger the hailstone gets. So it'll continue to get bigger and bigger until the updraft is too weak to lift it. And then in that case, the large hailstone can fall all the way back down to the surface. Hail can cause large amounts of damage to crops, buildings, and vehicles, and I suppose people as well. So this is a picture of a car that kind of got peppered with hailstones. You can see the little divots all over in it. And this is a runner that got kind of caught up in a hailstorm. Obviously you can see here where it was probably not very pleasant to be getting pelted by those hailstones while trying to run. Sleet. Sometimes raindrops fall through a layer of air that's very cold. Usually it's below 0 degrees Celsius, or it has to be below 0 degrees Celsius, which is the freezing point of water. So we get these little kind of crystals of ice or pellets of ice as they fall through that layer that is extremely cold, and they end up freezing into solid particles of ice. If those particles are smaller than 5 millimeters, then we call it sleet. So here's a representation of the different sized drops of water. If it's a cloud droplet, it's 0.02 millimeters. If it's mist, it's 0.005 to 0.05 millimeters. Drizzle droplets are 0.05 millimeters to 0.5 milliliters, and then rain droplets have to be a half of a millimeter up to a millimeter, up to 5 millimeters in order to be classified as rain droplets. So looking at this chart, what would be the air and ground temperature ranges for each of the precipitation? So if it's rain, the air temperature has to be above 0 degrees Celsius. Remember, 0 degrees Celsius is the temperature at which water freezes. The ground temperature also has to be above 0 degrees Celsius. So what about freezing rain? So the rain comes down, it's in water form. As it hits the surface, it freezes. So freezing rain has to have air temperatures above 0 degrees Celsius, and ground temperatures have to be at or below 0 degrees Celsius, because remember, as freezing rain occurs, that water droplet comes in contact with a cold surface and it freezes. Sleet. The air temperature has to be at or below 0 degrees Celsius. Remember, water's falling through the atmosphere, it hits a layer of very cold air, and as it falls through that layer of cold air, it freezes. The ground temperature, usually with sleet, is above 0 degrees Celsius. So usually sleet real quickly melts, and then we get water running off of the land or absorbed into the groundwater supply. Snow. Air temperatures have to be at or below 0 degrees Celsius. The ground temperature is usually above 0 degrees Celsius, or it could be at or below 0 degrees Celsius, much like sleet. Hailstones. Air temperature is going to be at or below 0 degrees Celsius. The ground temperature is usually above 0 degrees Celsius. Now it's also to note for hailstones, the atmospheric air temperature may actually be above 0 degrees Celsius in certain layers of the atmosphere. So it may be above 0 degrees, and then that hailstone gets blown way up into the atmosphere where the temperature is at or below 0 degrees Celsius, and then that hailstone falls all the way back down into an area where it's above 0 degrees, and that process happens over and over again. Ground temperatures for hail may also be at or below 0 degrees Celsius. Floods and droughts. So a flood is an overflowing of water in a normally dry area, or more specifically, just an overabundance of water in a given location. Floods usually happen every year, every spring and fall. So they can be small or large. They occur when the volume of water in a river increases so much that the river overflows its channels. These pictures were taken from the Ionia Free Fair, the Ionia Fairgrounds, I guess I should say, a few years ago during the B93 birthday bash. The river system ended up flooding during the B93 birthday bash, and a lot of cars that were parked in that area ended up flooding. Here's another picture of that. And another picture. During this storm, there was actually a very large amount of water that came down over a very quick period of time. There's a couple of dams along the Grand River, and those dams are used to kind of regulate the flow of water between sections, and Consumers Energy operates them. The story is that Consumers Energy called B93 and told them that they were going to have to open up a couple of the spillways to the dams in order to let extra water down, but B93 never relayed that information to the people that were parked out in the field. So people really had no idea that their cars were getting completely and totally flooded. A lot of people just stayed for the concerts and kind of ended up hanging out just while it was raining. And it wasn't until later on in the day that they realized the flooding had occurred so bad, and the rivers had overflowed their banks and ended up flooding all of their vehicles. A drought reduces the amount of surface and groundwater in a given area. Currently, California is experiencing this. Northern California and parts of our west are experiencing a very long, dry weather period where there's very little precipitation. They are actually calling this one of the worst droughts in recorded history. So they're usually caused by dry weather systems that remain in one place for weeks, months, or I suppose even years on occasion. So it's just an area of pressure. Usually high pressure systems do not promote cloud formation, therefore there is no rain that comes out of those systems. And so if they stay in place over long periods of time, you just plain do not get the precipitation you need for crops and farmland. So this picture actually came from Northern California. It shows an area or a body of water that is slowly evaporated and drying up due to the fact that there has not been more moisture added to the environment there.